Okay guys, we are going to review for our test. Get my pen working and let's go. So we're going to solve this and tell how many solutions. So we have to distribute first. So I like to divide my denominator into my whole number. 4 goes into 12x, 3x, and then I multiply it by my numerator and I get 9x. Then I multiply 3/4 times minus 8. So I say 4 into 8 goes 2, and then 2 times 3 is 6. When I multiply by a unit fraction, I'm really just dividing by that denominator. So this is going to give me 9x minus 5. When we have variables on both sides, we are going to get rid of the variables or get them on the same side. We can see that they're both the same, so I still have to eliminate them. So I'm going to use the subtraction property of equality. This gives me a false statement, so we're going to have no real solutions. Okay, here we have to get rid of our parentheses, so we're going to distribute, and I like to call it just double distribute. I'm going to multiply x times x. We learned this in unit 1. And then x times my minus 2. And then I have to distribute the positive 2. And then we're going to collect the middle terms. These are eliminated. And I have x squared minus 4. I can immediately see that I'm going to have infinite solutions if I wanted to continue. I have negative 4 equals negative 4, so I have infinite real solutions. Okay, here we have x squared plus 25. X is being squared, and then we're adding, so we're going to work backward and subtract. Subtract 25 from both sides, the subtraction property of equality. We are going to undo squaring, which is taking the square root. When I take the square root, I have to remember the positive negative. Now, look guys, you cannot have a negative radicand. There is no number in this course where we can multiply a number by itself to get a negative. So this is going to be no real solution. So make sure you put a big star and remember two things. When you take the square root, you need the positive negative, but then in this case, we're not even going to take the root because we have a negative radicand, so no real solution. Okay, this one looks similar, but it's different. So we have squaring and subtracting, so we're going to add first the addition property of equality. We're going to undo squaring by taking the square root. We're going to remember we have two roots, so x is equal to positive 5 and negative 5. So two real solutions. Okay, here we have a binomial on the left squared and a binomial on the right squared. You cannot just say x squared and minus 4, squared. You have to write these out. Again, this is from unit 1. Everything that we have learned, you are still responsible for knowing. I'm going to double distribute on the left side first. This gives me x squared. So I'm just distributing my x first. And then I'm going to distribute the negative 4. I get x squared minus 8x plus 16. I distribute the 4. I distribute the negative x. I'm going to write this in standard form and collect my terms. And I can just see here, if I'm just wanting to know how many solutions, I can stop here. And since I have identical expressions on the left and the right, we're going to have infinite real solutions. Any value will work to make this equation true. Okay, how many solutions here? We have to get the x by itself. It's being squared, multiplied, and subtracted, so we're going to work backward. Now we're going to undo the multiplication by dividing. We're going to remember that we are going to take the square root, so we need positive and negative. We have a positive radicand, so we do indeed have two real solutions. Okay, this looks similar, but it's different, so we are going to add 75 to both sides, the addition property of equality. Then we're going to use the division property of equality. And then as we take the square root of both sides, we notice the radicand is negative, so there's no real solutions. Okay, let's subtract 75 from both sides. Again, please pause the video whenever you need to pause it. I know I'm working fast. I don't want any interruptions, so I'm trying to get through these before somebody comes into my classroom. I'm going to take the square root, and I realize we have a negative radicand, so no real solutions. Okay, we are going to subtract. We are then going to divide by my -3, which then turns my constant back to a positive. So when I take the square root of both sides, I do have two real solutions, positive and -5. Those values will make my equation true. Okay, we're solving for x. X is being squared, then multiplied, then added, then divided. So we're going to undo the division by multiplying both sides times r. I'm keeping my eye on the thing I'm solving for. Excuse me. So I'm going to subtract k. I'm going to subtract it at the end of the already existing expression. I have to get rid of the 3 times, so I'm going to divide. So long fraction bar keeps that top part root together. So I have x squared equals qr minus k over 3. Then I'm going to take the square root and let's change this. When I take the square root, don't forget the positive and negative. So my final answer is x equals positive negative. Make sure everything's up underneath the radical. And there we go. Okay, next. This looks similar. We're doing the same thing, but this time we have one addition operation. The minus w needs to be moved first. So we're going to undo the w. Now we need to get rid of the r, so we're going to multiply. We do have to have parentheses on both sides. We have addition right there. Do not distribute. Just leave it just like that. Let's subtract k. It comes at the end. We have 3x squared equals r times q plus w minus k. Now we need to divide by 3. And then we're going to take the square root. And when I take the square root, I'm going to remember my plus and minus. Here we have inequalities. So this one is compound. I can do this all as it is. I don't have to rewrite it. You could. So whatever I do to the middle, I have to do to the left and to the right. So I'm going to say minus 4. And I have to divide everything. And look, guys, look what I'm dividing by. A negative. Big star. So this gives me positive 6. I have to reverse the inequality because I divided by a negative. Reverse this inequality because I divided by a negative. So let's graph this. So x can be greater than 6, but less or equal to 8. So there is my solution set. If I write this in interval notation, I go from left to right, so the solution starts at 6 but doesn't include it, goes all the way up till 8, includes it. So interval notation would be parentheses 6, comma, represents all your shading, 8, and bracket. French curly bracket for set builder, I'm going to just take my inequality. X is an element of the real numbers such that, and then I have my inequality, and then my French curly bracket. Okay, again, I'm just going to leave it as is. I have an 8 to get rid of first. So subtract it out from all 3 places. That's a negative 4x in the middle now, or always was. I'm going to be dividing by a negative. So I'm going to reverse my inequality symbol. I have negative 2 and negative 1. So make sure you do your number line correctly. So x is less than negative 2 and not equal. So going toward negative infinity. And then x is equal to negative 1 or greater going toward positive infinity. So when we do our set builder notation here, I go from left to right. So it's going to begin at negative infinity, go up to negative 2, not included. It's going to skip over this space and then pick back up at negative 1, including negative 1, and then goes all the way to positive infinity. So interval notation is going to be parentheses, negative infinity, comma, that represents my shading, negative 2, parentheses, union, and then we have, whoops, this should be a bracket, equal bracket, it's included. Negative 1 is included, shading, positive infinity, and parentheses. Okay, here we have an or. We're just going to solve the left one and then the right one. So I have to add 6 to both sides. I have negative 6x is less than or equal to negative 30. I'm dividing, and I'm dividing by a negative. I'm going to reverse my inequality and get 5. So we can say the word or we can use union. And then here we're going to add 2. We're going to divide by 4. X is less than 3. Let's wrap this. I have a 3 and a 5 to consider. It says x is less than 3 and does not equal. It says x is equal to 5 or it's greater. Interval notation, so we're starting at the left and working our way right. So we have negative infinity, comma, 3, parentheses, union, bracket, 5, comma, positive infinity, parenthesis.